Okay, so we want to look at the last type of bond we want to use to understand how to determine interest rate. We're going to focus on the discount bond. Now, the discount bond is actually a non-coupon payment bond that promises repayment of the face value sold at a price below the face value. So the yield to maturity on such a bond, like the discount bond, could be determined using the normal present value formula that we know, which is present value equal to, that is this, divided by 1 plus r exponent L. So we can determine the yield to maturity using the normal present value, since the promised face value could be taken as the future value and the bond price as the present value, so that we solve for the interest cost that equates the future value to the present value. Okay, so I said that we are looking at this as the bond price in this case, and then we are looking at the future value as the face value. Let's take an example. We want to determine the yield of a 1 year discount bond that sells at, so N is what? 1, that sells at 720 Ghana cedis. Okay, so remind you, we said that the bond price are going to take it as their present value. So in this case means that 720 Ghana cedis would be equal to FV divided by 1 plus R. Here is going to be exponent 1. No number exponent 1, we can just forget the exponent 1, but let me just write it. So we want to assume that the face value is 1000. We've been using 1000 in all our examples. So using 1000, we just calculate, we make R the subject, and then we are good. So this is a fraction. How do we get rid of a fraction? By multiplying through by the denominator. So I'll multiply both sides by the denominator, which is this. So I have 1000 over 1 plus r times 1 plus r. This will cancel this. Then I'll have 720 times 1 plus r equal to what? 1000. Now I want to make 1 plus r the subject so that I can further make r the subject. Means I have to divide both sides by what? 720. Great. So I can have 1 plus r is equal to 1000 over what? 720. I can further make r the subject by sending 1 here. When 1 crosses the equal sign, it's going to change towards negative. So I'll have 1000 over 720 minus 1. When you do your calculation, we are going to get 38.89%. 38.89%. That becomes our final answer. Now the formula for the yield to maturity on a discount bond could also be summarized in a particular way. You can summarize it as R equals FV minus PV divided by PV. Okay. We can also have the same R equals FV minus PV over PV times 360 divided by number of days to maturity, number of days to maturity. And we can also have, in a case where number of days maturity is up and then 360 is down. In that case, you see the formula is modified slightly. When the period of discount bond is less than a year, when it's less than a year, we bring the number of days up, the 360 comes down. But if it's more than a year, we bring the 360 up, and then we divide by the number of days to maturity. And that is how we can find the R, or the rate for discount bond. Thank you.